What distinguishes between trainable and hidden variables? Like, do
Right.
physical
Mm.
entities correspond to some, or even mental entities correspond to one, not the other, or what?
So the hidden variables in this case are like hidden neurons, and their states are described by non-trainable variables. Something that, all of the non-trainable variables in neural network are connected by trainable variables, called weights. So kind of you cannot like just draw a sharp line and say here's the trainable and here's not trainable. Very much like in physics, you cannot say here's electromagnetic wave and here are electrons. They're coupled. They're all communicating through each other. Now, the difference of a hidden non-trainable variables and a physical non-trainable variables is that the one that are physical, they've organized themselves in these three-dimensional structures, and they've kind of discovered the effectiveness of using three-dimensional space for exchanging information and minimizing their loss function. The hidden space at this point, they can have arbitrary connections to each other. Maybe a good idea to think about initially you have a soup of neurons, everything is connected to everything, and it's all hidden in a sense that no physical space had yet emerged. And then there is bubble form, a big bang, and then there's certain number of those neurons figured out that they can learn a lot more. It's like transition, and can minimize their microscopic loss function if they arrange themselves in the three-dimensional space. So if that phase transition took place, then you still have the hidden variables, which you can always hire if you need to do calculations, but they need not be present in your physical space. They need not interact with the classical degrees of freedom. They still interact by providing you with this quantumness, but they need not be directly observable and coupled. So that's the model for them. So and it is correct to call them hidden variables because hidden variables is one of those. It's called interpretation quantum mechanics, but I guess it's an attempt to actually make quantum mechanics a little less mysterious. Trying to actually, it comes with its own problems, and we can certainly talk about them. But at least it doesn't it tries to put less stuff under the rug.